Now question number 7. This flowchart represents an algorithm. Now you can see what is the flowchart. Let's see. Start, output, continue. Input answer. If is answer equals to y, yes, input value 1, input operator, input value 2, and is operator equals to a, so it has to perform output value 1 plus value 2, and the arrow is directed back to the continue thing. Otherwise, if that is not the case, it is going to move down to the second situation. Is operator equals to s? Yes, output value 1 minus value 2. If no, it is going to down to check for the third condition. Is operator equals to m? Yes, value 1 into value 2. No, it is moving here and value 1 upon value 2. And here you can see in all the situations, the operator is a, s, m, or not. It is moving back to the top, and continue is again a question here. So this is my simple flowchart, giving you 2 minutes to go through yourself, and then we will understand this whole trace table, okay? Giving you 2 minutes, very quick. Understood very well? Okay, now let's move. First statement, first box, box, as you can see, is output, continue. That's why continue is coming here. And then input answer, we have taken the first y, that is in my answer. Is answer equals to y? Yes. So it is moving here, input value 1, operator and value 2. So value 1 is 7, operator is s, and value 2 is 9. So in this manner, y7, s9, y for continue, yes, 7 value 1, operator is s9. So you can see here, it moves here. Is operator equals to a? No, it moves down. Is operator equals to s? Yes. It is outputting value 1 minus value 2, means value 1 is 7, minus value 2 is 9. So 7 minus 9 is minus 2. Be clear, it is minus 2. Then it is moving back to the continue, and you can see continue question mark. Be clear, C capital ONTINUE question mark is supposed to be written completely the way it is written here. Input of answer again. So now it is the second value, as you can see here. Y5, just with a different color coding to make you comprehend. Y moving to answer. Now you can see, is answer equals to y? Yes. Input value 1, operator value 2 means 5 is in value 1, m is in operator, and 12 is in value 2. Now you can see A is not the operator, S is not the operator. So it is moving down, and is operator equals to m? Yes. Value 1 into value 2. 12 times 5 is 60. 60 is written here. You move back to the top to find out, to move here. Output continue. After 60 is output, you can see continue is again appearing in your output column. Again the same, continue question mark. Input answer. So which is the second next input? Again, answer is y. Y here. Is answer equals to y? Yes. It moves here. Input value 1, value 2, and operator. So it is going to be y is the answer. 25, D, and 5. So 25, D, and 5. So you can see it is going to be moving here. Operator is not A, operator is not S, operator is not M. So it is moving to the situation here, and value 1 upon value 2. And then it will be dividing 25 by 5, and the answer is 5. And that is written here. Again moving back to continue, and here answer is N. Answer N means, is answer equals to Y? No, it is stopping the program. So be clear, the other values here are not supposed to be a part of your flowchart at all, because they, after N is input, the program will stop. The program will not continue at all. Understood? Yes or no? Now making sense? Okay, that's great. To be clear, this is why they have tricked you. A 5-mark question dealing with this option that 10A and 6 will not be inputs. If a student writes these, it means his answer will not be considered to be completely correct. So this is how they trick you actually. Any issues? Okay. State the purpose of this algorithm on page 6. So it's so simple. You can see for yourself. It's a calculator. So it's say asking you to state. So you will simply state a calculator. That's perfectly okay. Now there are problems. Now part C. There are problems with the given algorithm. If the lowercase letter y is entered for answer, the algorithm stops. And if a lowercase letter is entered for operator, the algorithm gives an incorrect output. See, this is for yourself. You must have identified yourself that it's dealing with capital Y only. It means if, for example, the caps lock is off and a person entered small y, so it will end the program. Although the person will be perplexed that why has it ended. Similarly, if a lowercase operator is entered, maybe a person entered small a or small s or small m, in all the cases, the work will not be performed. The calculation will be inappropriate, will be incorrect. Explain how would you change the algorithm to prevent the problems being described. Now, just think about it. See, y being entered, fine, perfect. But in case if the y was not entered in capital, y was entered in small. So similarly, all the options, if they are entered in small, so the program will stop abruptly. Okay, that's great. Think about it. It's Ahmed, excellent that we can try out that a person has entered y or small y. Perfect. Same case goes for y only, or should we check the same for a, s, or m also? Exactly. All the alphabets should be checked in this manner that we can go with an or situation. We may have we can write an or situation here, or we can use another box here. Both are okay. Perfect. Perfect. There's no mistake. See, yeah, explanation is needed. Explain how would you change. So what can we do is we can use two process boxes after the answer and operator inputs are taken. And we can use a U-case function, as you remember, to change the input to the uppercase. That is one option. Like one option is a child can write that I am going to use, after the two inputs are taken, I am going to use two more, I'm going to use two process boxes, and I'm going to use U-case function to convert them to capital, to check to convert them to capital letters completely. So it means that if it's already capital, nothing is going to happen. But if it's not capital, then it will convert to capital. That's perfectly okay. Or another child, as Mehmet was mentioning here, what can happen is you're going to change the conditions in all the 4 process decision boxes. And we have to change in this manner. We can say or answer equals to y. Similarly, or operator equals to a, or operator equals to s, or operator equals to m. So we have to use we have to change the condition in all the 4 decision boxes, the way Ahmed has mentioned. So they both are the correct answers. A child can write any of the answer. Explanation done properly will definitely give him 3 out of 3. Okay, understood? Now, identify one more error related to inputs when the algorithm is run. Okay, if you have observed, we have talked about it. In all cases, the operator is not A or S or M, so it is definitely going here. Maybe a person entered a wrong letter. His hand has touched the wrong key, so it was not A, S, or M. So in that case, in all cases, you can see the 4 options at the top are wrong. Are like the A, S, or M is not there. So it is in all cases going for the division process. So that is actually a problem. So it is only testing A. Now there are identify one more error. One more error is supposed to be identified here only. So you can see a child can choose that a child may have seen that it's going to be AS or M are only checked. So if assumed it is, in all cases, it is assumed it is going to move to D, division, which is wrong, which might be wrong. Division by zero, exactly. Like, although there's an option that a person has entered value 2 as a 0, so it will result in your wrong value. Maybe the wrong data type, exactly. Maybe a person has entered a character instead of a number, because we're not checking any, we're not performing any validation check here, exactly. Or no data is entered, it's all blank. So these are all the options available. So a student can write, can choose any of these, and his answer will be considered to be the correct answer.